Hello everyone. This video tutorial is about modeling of combined twinning and disorder, actually a whole molecule disorder, using the OLEX2 crystallographic software. For the structure solution and the refinement, we are utilizing the SELEX-T and SELEXL, a very popular program written and maintained by Professor George Michael Seldrick from University of Göttingen, Germany. The necessary files are provided by Professor Sean Parkin from University of the Kentucky. This is actually the molecule uric acid dihydrate. This is the structure. In this molecule, we are going to handle the twinning and disorder combinedly using the OLEX2. The total formula of this compound is definitely C5H8 and 4 and O5. So let's begin the refinement. Here the twinning is caused by pseudo-merohedry by virtue of the beta angle very close to 90 degree. So then go to work and solve. We are using the program SELEX-T. Method is interesting phasing. The file name is uad.htl and the molecule formula is C5H8 and 4O5. So let's press solve. Now the solution is like this. Okay. So if we assign the atoms, no, it's okay. So this is CO group, this is nitrogen, it should be nitrogen, make it nitrogen, and then make the oxygen, which is dihydrate. So these are the oxygen. Now it seems to be nice. So let's first name them systematically. Go to naming. Start with 1. There is no need of suffix. Type is carbon. Name C1, C2, C3, C4, C5. Then oxygen oxygen O1, O2, O3, O4, O5. Then nitrogen N1, N2, N3 and N4. Then go to sorting, sort. So now escape, go to file, shift, then O1, O2, O3, N1, N2, N3, N4, C1, C2, C3, C4, C5, O4 and O5. Now save it and refine. For the refinement, we are using the program SELEXL, the least square method, cycles for lesser 10. It's a small structure, so number of cubics are 15 enough. Then apply ACTA for the generation of zip file, also applying the weighing scheme, and then refine. So R factor is around 13.6. There are some cubics with highest electron density 1.1 electron. Then again refine so that the shift can stabilize. One more time. So at this stage, if you refine it anisotropically from here, and then we add the hydrogen, refine one more time so this shift gets stabilized. One more time. Okay, if we add the hydrogen, fine. More time. So the R factor is not getting down. So we have to consider the twinning and disorder. So let's first delete all the hydrogen. For that, cell $H, then kill. Define isotropically. Okay. So first let's handle the twinning. For this, go to the zip file, ins file, type here twin 100 minus 1000 minus 1 and batch scale factor BASF. Suppose let's start with 0.7. So how to generate this twin law we will discuss in some other video, but here we are just introducing the twin law 100 0 minus 10 0 0 minus 1. The twinning is caused by pseudo-merohedry and batch scale factor 0.7. We are supposing the first component is 0.7, okay, 70%, and the rest is 30%. This is just the initial gas. Let's do the final refinement. Then go to save, exit, and then refine. Now the R factor is down to 10.24. It's okay. Refine one more time. Yes, the R factor is around now 10.42. If you look at the structure, it has some Q peaks, Q2 0.85, Q1 around 1 electron. So this atom in part is appearing here, and this oxygen O2 in part is appearing on Q1. So select the atoms, okay, then go to split same, and now rotate like this. Here. Okay, now press the escape and refine. It's nicely working. R factor is down to 6.84. That's nice. Refine one more time so the shift gets stabilized. Okay. Then type anis, redo, and refine. So R factor is further down to 6.01, but some atoms are getting non-positive definites, but don't worry, just select them and type EADP. This one is also up. EADP, 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 EADP. Okay, so let's refine then. Now everything seems to be good. The thermal parameter is quite nice. Refine one more time. Okay, go to add hydrogen. R factor is further down to 3.81. That's nice. Select this one. Type H823. 43. Refine. Define one more time. Now the R factor is stabilized to 3.76. Here everything seems to be green. Then define one more time, so this become green. Okay, I'll go to edit. So if you can see, the restraints are automatically written and batch scale 0.1. Only the second twinning component is about 10.7%. And the disorder part, the second component is only 20%. First is approximately 80% and the second disorder component is 20%. The first twinning component is in twinning, the first component is around 90% and the second is around 10%. Thanks for watching the video.